So we would like to determine how to check the capacity fade in a 1D battery model. So we're going to use a 1D battery model in Comsol multiphysics to predict the capacity in the battery over a period of time and its aging over a period of time. So at the end, we should be able to plot some results showing the capacity cycle with respect to time, how it changes with respect to time, and also the state of charge as well. So we should make a plot of this as well during this study, showing the discharge curve comparison over a period of time, different cycles, and also the cell voltage during discharge for different cycle numbers. And also we should be able to make a plot of the state of charge at the separator and the electrode boundary, different cycles, the first and the last cycle for the different electrodes. And finally, show the plot of how the capacity ages or varies over a period of time. So let's get started. So at the beginning, we move to our new, go to our model wizard, then from our file, we look at our application libraries. When we open our application libraries, it brings us to this space where we choose lithium-ion batteries and we select capacity fade. We select the capacity fade seed. We open. So when you open, it will take you to the interface and you see all everything defined, the variables. As you can see, variables have been defined over here. So it's actually inbuilt. All these things are inbuilt in the Comsol setup, depending on the model that we are using. Let's go to lithium-ion battery, electrode, everything. You can see it has already been, the domain has already been selected. Open our particle electrode. Has actually been defined. Most of the variables have been defined. To the pros electrodes. So this is basically how it is. And if you should check the materials, you see that it's actually added materials to it. The electrolyte, negative and a positive electrode have been added to it. Go to the initial cell charge distribution. You can see everything has been input over here. So we go ahead to add a charge discharge cycling to it. That will be the first work, and we'll select our domain as form. That is all we select for this section. Discharging current we set as minus I. Minimum voltage we set as E. Maximum voltage will be max. And charging current will be set as this. Then we check this side, which is include constant voltage charging. And we set this side, which is the upper cutoff, as charge. We would like to start, we go to the start mode, and we want to start with the charge first in this section. We have to press electrode 1, where check 2. We want to add SEI as rho SEI. We want to make this here this way. That's our dissolving depositing species. We set it as SEI. We define the density and the molar mass as well. We go ahead to check this add volume change to, we uncheck this part. And also the film resistance, we want to change it to thickness and conductivity so that we can define the reference film thickness, which we define this way. And we also want to change the film thickness. We want to change it to total film thickness this way. Film conductivity, we want to change it to to this. Move to the porous electrode reaction one. We check everything. Then we go and we add the porous electrode reaction to the second one for porous electrode. So over here to go to the electrode kinetics. Then we make here user defined. So we can input our I. Let's go SEI. Cycle. And let's go number greater than 0. This way. Move to our variables. And we check to see if everything is defined. As previously, those which were in yellow are now black. Everything is now black, as you can see. Go back to porous electrode reaction 2. And we check our coefficient over here, which will make it T underscore factor -1. That is geometric coefficient for V I theta. We go to our parameters and we check our T factor, that's time acceleration factor. Okay, 250, yeah. So move back to our porous electrode 2 so that we can set our SEI to be T underscore factor. Our temperature should be user defined. We go on to definitions to add an integration. where we select the negative electrode. We move to our study. And before that, I want to show default solver. We move to our current distribution initialization. We want to check if everything is in line, but first we will actually modify this part and go ahead to disable our pros electrode reaction too. So you could either click here or just disable over here. Now it's disabled. Our pros electrode reaction too. So you go to current distribution, then you go on to disable pros electrode too. Let's open this solver. On our time dependent solver, let's add a stop condition. So we want to add a stop condition to this. That cycles. And we also want to add changes part to steps before and after. So this section, we want to uncheck this part. Move to our study. Want to uncheck generate default thoughts. So before you study, you need to go to, you need to check all the areas to see whether there's no mistake, especially for the pros electrode reaction 1 and 2. So we check that it should be thing that I've done over here. Material should be graphite, equilibrium material, kinetics as well. This way carefully set it. So this was what we made some changes over here. At the equilibrium potential should be user defined. Kinetics user defined. So we go ahead and compute. We have our convergence plot. So we have this. So we move on to close this. I want to add one B plot group. I want to add a one B plot group to plot some results, which we'll name as load cycle. Name this as load cycle with the title type will be none. Plot to y-axis. Our load cycle, we want to add global. We want to input this expression and cell. So now variables ISO is already stated. Move to global. We want to duplicate this. We want to filter as well. We want to put a logical expression over here as first cycle filter. even stated in here. We move to global 2. And we want to delete this global 2. Just maintain this global 1 and duplicate it as well. We want to check this. We want to change this expression here to E. When we plot, this is how it should look like after plotting. We want to add the plot group, change the expression to discharge is comparison. Title to none. Y-axis, rename it as cell potential. Want to add a global. I will name this as the first cycle. Want to put this expression in cell. Direction. Want to check and make the parameter an expression. To input our expression as team as this. This will be our expression for our parameter. And we go ahead to filter and we check this as first cycle filter charge filter. So So this has to be, let's go. It's just a star over here. First cycle filter. It's a filter here. Yeah, and you're able to plot it. Move to the variables. See, first cycle plotted. Go ahead to duplicate this. How about we check the last cycle? And make this description cycle go to 200, 2000. And we go ahead to filter and make this the last. So we plot, we see. That's the cycle for. So we make here description cycle for 1. Make the comparison a bit better. We plot. This is the first cycle, and this is the cycle for 2000 to 2000. Go ahead to add a 1D plot group. Change this to SEI, layer potential drop at 1C. Change title. Y-axis. And we change the title to this. And go ahead to label the y-axis as potential drop over let's make this potential drop over CI layer. Go ahead to add a point graph. select what we want to check. We'll put our expression in here. Change your parameter to an expression. Change the expression over here to cycle number. Change the description to cycle number. Change the things to at negative electrode current collector. We move ahead after adding move to add a filter to it. So we label this as PCH start and filter. We'll duplicate this. This selection, change it to here. We delete this. And here is start with the separator. To show our legends as well. We duplicate this and change this to electrolyte. Um, y-axis level changes to electrolyte fraction. And go to our points of change this to yes. We change that of when you have to down one plot. We have this. Plot. We have this graph. I want to add another one, the plot group, which we'll call capacity fade versus time. So capacity versus time. I'll try to be none. Y-axis show the time and days. Then show relative capacity. Go ahead to add global. This becomes Q minus 1. Q score share 0, 0. Change the parameter to expression where I name this as T. Pattern. let's choose description. I want us to choose time as base. We show legends to now. And we want to show this as based on lithium. Go ahead to add a filter to this. Minus charge filter. Want to duplicate this and to see one dot two underscore d which starts one which change your legends to nominal one to charge capacity. So we will duplicate this. Change this to this is cycle number. Change this to cycle number. Expression change to cycle number. Send this to the scene. Plot add another one D plot group. Local state of charge at separator electrode interface. This manual. Y-axis is SOC. We add a 4-point global. We add a point graph instead. So select put the expression SOC OC underscore surface SOC LOC. This is right. Make sure everything is right. Parameter expression. Choose to cdc.t underscore switch. But we want to show our legend. So need to show this photo. It's probably let me retype this again. Make your so legends show negative electrode to first cycle. Let's add a filter. It will be the first cycle underscore filter. We want to duplicate this point. And graph. We want to select deselect this and select side 2, 3. This will be positive. We want to duplicate this again. And change the filter to, want to duplicate and change the filter to last. Sorry. Last. See. I want to duplicate this. Point graph 2 and select it's already selected, so select again here. Okay, so we have 4. 1, 2, 3, 4. Already selected. Already. We move to, want to check how variables will actually look. So in our battery, we go to how about look at cross electrode reaction. So this shows the local current density. Before that, for this I'll plot for our local state of charge at separator, electrode charge cycle. Title, attention. So basically that's it. Being able to plot our graphs, and this brings us